sorry, but I'll try to make up for it with a good presentation. So first of all, I did an independent study last semester with Mr. Patel, and at first, last year when I approached him, I didn't know what I wanted to do. I knew I really liked working with him. I had him for AP chemistry. I said, I really want to work with you. Do you have any ideas of what we could do? And I think a couple days ago, before I asked him, he had seen a computer science project I was working on. And then he told me, you know what, John, maybe my students have some trouble understanding some things like gas laws, titrations, and maybe we could use technology and computers to help make them understand it better. And that was something I really liked because I really like programming computers and I also really like teaching people. So we did. We created an application that helps explain the gas laws to students, and that's what I'm here to present today about. So one of your first questions might be, what are the gas laws? Unless there are chemistry teachers in here, you probably know what they are. So the gas laws relate various qualities of a gas: pressure, temperature, volume, etc. And you see them in your daily life with balloons, with rice cookers, and in scientific applications, manufacturing airbags, sodas. So, as I said before, the gas laws that we're going to deal with, they measure four qualities of a gas: the amount, the volume, the temperature, and the pressure. And many people have a good understanding of this. Is this thing ringing? Because it's...
Going to turn it down a little bit?
Okay. Sorry about that.
Don't hold the top of it. Don't. There you go.
That better?
Yeah.
Okay. Sorry. So they relate the four qualities of a gas: the amount, the volume, temperature, and the pressure. And many people have a good understanding of this at the macroscopic level that we deal with. You know, temperature is something's hot or it's cold. Pressure is like a pressing force you feel when you swim down to the bottom of the pool. But at the atomic and the molecular level, these things manifest themselves very differently. Temperature at the atomic level is not how hot or cold a particle is, it's its speed. And that's something that might seem counterintuitive. So we want to help students get an understanding of how things at the macroscopic level, if it's hot or if it's cold, manifest themselves at the atomic level. Oh, it's moving slower, it's moving faster. Because those things aren't always intuitive at first thought, but they're very essential to getting a holistic understanding of whatever field you're in, whether it be chemistry or physics or economics. So before I talk anymore, I was going to give a demonstration of my gas law simulator. It's not working, but I'm going to try to describe it for you. So when you first open it up, there's a main menu, and you can choose between four common laws that are taught. You know, Boyle's law, Charles' law, Gay-Lussac's law, and they all relate volume, temperature, pressure. And what the students do is they just use it. And so at first we don't want to say, oh, you have to do this or that. They just open it up and they experiment. And then through the experimentation and seeing how that changes the gas particles in the gas chamber and all the different data, they can sort of develop an understanding. And then we can say, now let's quantify this. Let's collect some data. So the pressure is at this amount of atmospheres and the volumes at this amount of liters, and let's try to mathematically figure out a relationship. So the students at any skill level, if the students are in an intro to chem class, they don't have to go as far as mathematically quantifying the laws. They can just experiment with it. And if you're an AP Chem student, you can use it to review. And so I tried to develop it so students at any skill level could use it, and it wasn't some esoteric application that only the enlightened few at Lake Forest High School understood. So the four gas laws that this application covered are Boyle's, Gay-Lussac's, Charles, and Avogadro's. And the reason we picked these four is because they're taught to all levels of chemistry students: intro to chem, AP Chem, honors chemistry. So we wanted to, as I said before, let everybody be able to use it. And one of the biggest challenges for studying science is getting a holistic